When we start talking about probabilities that involve two or more events, we have to start thinking about whether those events are independent or dependent. Two events are considered to be independent if event A occurring does not affect the chance of B occurring. So if A and B are independent, then the probability of A and B is just equal to the probability of A times the probability of B. In example 5, we're told that a fair coin is flipped 2 times. We want to find the probability of getting tails on the first flip and then heads on the second flip. Flipping a coin, every time we flip it, is an independent event. One outcome doesn't impact the next flip. So all we would need to find in this case would be the probability of getting tails on one flip and the probability of getting heads on another flip, and multiply those two results together. Every time we flip a coin, we have a 50% chance, or 0.5. So this would be 0.5 times 0.5, or 0.25 probability. In example 6, we're told that an ace is randomly drawn from a fair deck and then replaced. That's a key piece of information for this problem. And then we want to know what is the probability of drawing an ace the first time and an ace the second time. Since we make that draw and then replace the card, each time we're selecting from that complete deck of 52 cards. So these are two independent events. So all we need to do is find the probability of drawing an ace and multiply that by the probability of drawing an ace, which would be 4 out of 52 times 4 out of 52 to give us a probability of approximately 0.0059. If two events are not independent, then they're dependent, which means one outcome occurring impacts the probability that the second one will occur. In example 7, we've got something very similar to example 6, but this time around that ace that we draw is not replaced. This means we can't calculate the probability the same way we did in example 6. Instead, the probability of getting an ace on the first draw and an ace on the second draw will be 4 out of 52 for the first draw, because there are 4 aces out of 52 possible choices. But then we need to multiply that by some reduced values. Now, assuming one ace is gone from the deck, there are only 3 aces remaining out of only 51 possible remaining cards. So the probability of that second draw has been impacted by the fact that we took a card and kept it out of the deck. But once we have those updated values, now we can multiply these two values together to get an approximate probability of 0.0045.